Cek satu dua. Cek satu dua. Oh.
Ya, Bapak Ibu hadirin, kita akan memulai acara kita di saat ini. Namun sebelum itu ada sedikit informasi bahwa bagi Bapak Ibu yang ada dalam ruangan ini untuk tidak mengikuti atau join dalam Zoom agar nanti suaranya tidak terjadi feedback. Ya, terima kasih atas perhatiannya. Selamat pagi, Assalamualaikum warahmatullahi wabarakatuh. Om Swastiastu, Nama Budaya, Salam Kebajikan, dan Salam Sejahtera bagi kita semua. Shalom.
Good morning, ladies and gentlemen, all of the invitees and all of the invited speakers.
Yang terhormat, Direktur Program PASCASARJANA Universitas Pattimura, Profesor Dr. Domingus Male, MSc.
The Honorable, the Directors of the Postgraduate Program of Pattimura University, Professor Dr. Domingus Male, MSc.
Yang kami hormati, Profesor Amanda Rachel Bruset, mohon maaf jika terjadi kesalahan pengucapan.
The Honorable Professor Amanda Rachel Burchett, we are so sorry for probably we might mispronounce your name. Thank you so much.
Para Wakil Direktur Program PASCASARJANA Universitas Pattimura,
The Vice Directors of the Postgraduate Program of Pattimura University,
Bapak Moderator,
the moderator for the public lecture sessions,
para Koordinator Program Studi Program PASCASARJANA Universitas Pattimura,
all of the coordinators of study program,
Bapak Ibu dosen dan staf,
all of the lecturers and the staffs of postgraduate program of Pattimura University,
Bapak Ibu mahasiswa Program PASCASARJANA Universitas Pattimura,
and all of the students of postgraduate program,
serta seluruh tamu undangan yang berkenan hadir di saat ini.
along with all of the invitees who present in today's public lecture sessions.
Selamat datang dalam acara kuliah umum tahun ajaran 2023-2024 PASCASARJANA Universitas Pattimura dengan tema Good Sampling and Laboratory Method for Publications.
Welcome to the public lectures for academic year 2023-2024 under the theme Good Sampling and Laboratory Method for Publications.
Adapun susunan acara di saat ini yaitu 1. Menyanyikan lagu Indonesia Raya.
Hereby, this is the agenda of today's public lecture. The first, singing the Indonesian national anthem, Indonesia Raya.
2. Sambutan oleh Direktur Program PASCASARJANA Universitas Pattimura.
Secondly, the welcoming speech by the Director Programs of Postgraduate Program, Pattimura University.
3. Doa.
The third, prayer.
4. Kuliah umum oleh Profesor Amanda Rachel Bruset.
The fourth, the public lectures by Professor Amanda Rachel Bruset.
Dan yang terakhir, penyerahan sertifikat dan sesi foto bersama.
And the last will be the certificate handover and the photo sessions.
Bapak Ibu hadirin yang saya kasihi, kita masuk ke agenda yang pertama yakni menyanyikan lagu Indonesia Raya. Hadirin dimohon berdiri.
Ladies and gentlemen, we are going to sing the Indonesian national anthem. We invite you to stand for a moment.
Hadirin dipersilahkan duduk kembali. Bapak Ibu hadirin sekalian, kita akan mendengarkan sambutan oleh Direktur Program PASCASARJANA Universitas Pattimura, Profesor Dr. Domingus Male, MSc. Kepada Bapak dipersilahkan.
Ladies and gentlemen, now we are going to listen to the welcoming speech by the Director of Postgraduate Program of Pattimura University, Professor Dr. Domingus Male, MSc. For the Director, the stage is yours.
Sekalian belajar ya. Good morning. Welcome again, Mandi. It's not like too formal for us, so we just relax and just for this general lecture. Well, first, we would like to thank you very much for Professor Amanda for giving your time, sharing your best practices and your experiences for us. And well, I think this is a good opportunity for us, particularly for the students who are willing to do research either in the field or in laboratory work. So, Professor Amanda, or I usually call her Mandi, has a good experience and a lot of work in Maluku, particularly in Buru and Seram. So we were working together in several research topics, and there is a group in Pattimura University who is that working with Prof. Amanda based on our collaboration agreement between Pattimura University and Southern Cross University. And actually, we have some good results from this collaboration. So one is the Prof. Justinus Male, because he got some publications from the work with Prof. Amanda. And also there is a PhD graduate, Dr. Endang from Fishery Faculty. So this is the results from the collaboration between Pattimura University and Southern Cross University. And also we had some visits to Lismore in Southern Cross University in some occasions, I think, because Prof. Yus also went there in 2019 and 2012, and the second 2019 together with me, and also Rector and Prof. Mose also went to Lismore. Yeah? So if you have some interest to visit Lismore, Southern Cross University, you can conduct some data collection there, or maybe you can do some what called analysis, laboratory analysis, because Lismore, Southern Cross University has very good laboratory facilities that you can use it, and also it has a lot of very big station, seperti yang kita punya di Hila, but Southern Cross University has bigger than very complete. Yeah? So for the students who will do research, particularly in marine sciences, or some activities related to marine sciences, it's a good opportunity to listen to Prof. Amanda's general lecture this morning. And for your information that starting from this year or maybe next year, Pattimura University will return back to its foundations or its philosophy, Bina Mulia ke Lautan. So, because actually we forgot already in some times, and then we need to go back to the philosophy of Pattimura University, Bina Mulia ke Lautan. So, all energy has to be put into the marine sciences in all aspects, not only marine or fisheries, but all like educations, laws, social sciences, yeah, and also like medicines. Everything should be directed to the philosophy or the foundation of Pattimura University. And thank you again for this time Amanda has allocated for us. So just follow it and get the best from this lecture. And also, I hope that we can gain more informations, especially for the students. So again, Amanda maybe will leave soon, yeah? So actually, Amanda with the husband, Dr. Don also came, but he left already. So I was wondering this morning because I did not meet him. Okay, and also thank you for Prof. Mose for being the moderator. And so by giving thanks to the Almighty, I officially open this general lecture.
Terima kasih Pak untuk sambutannya sekaligus membuka dengan resmi kegiatan kuliah umum kita di saat ini.
Thank you to the Director of Postgraduate Program for simultaneously opening our session today officially.
Bapak Ibu hadirin sekalian, kita akan beralih ke acara selanjutnya yaitu doa. Dengan ini hadirin dipersilahkan untuk menundukkan kepala sejenak untuk berdoa menurut agama dan kepercayaan kita masing-masing. Berdoa dimulai.
Pray.
Berdoa selesai. Bapak Ibu hadirin, kita akan masuk ke acara yang kita tunggu-tunggu yaitu kuliah umum oleh Profesor Amanda Rachel Doucet dengan tema Good Sampling and Laboratory Methods for Publications. Sorry. The tema is Field and Laboratory Research for Publication. Dengan moderator di saat ini yaitu Profesor J. Mose, PhD.
Ladies and gentlemen, now we are coming to the public lecture sessions. Without further ado, let's extend a warm welcome to our distinguished speaker, Professor Amanda, and her pioneering work in the field and laboratory research for publications is expected could widen our horizons at this moment. Please join me in giving her a warm round of applause.
All right. Selamat pagi, Pak Direktur yang saya hormati, Profesor Amanda, yang juga saya hormati seluruh mahasiswa yang sangat luar biasa. Ini semester 1 dan semester 3 ya. And we expect that all postgraduate students should be here. And I think I have to also welcome all audience at the moment join with us through online. Am I right? Hello, good morning everyone from outside there, somewhere. Hello? That's good. Wow, a lot of crowds over there. Okay, that's good. I haven't seen your faces anyway. Where are you? Okay. Once again, thank you so much for this wonderful morning. Especially, I would like to thank you, Professor Male, Domingos Male, for hosting us. This is precious time for, especially for Amanda as well, because it's for you to know that Professor Amanda is on leave from Southern Cross University. So practically, she's on holiday. But because she's so precious, one of the renowned scientists in her field, that's why we feel so privileged to have her here at the Pattimura University. So I really do hope that all of us who are present at the moment in this room, as well as those join with us through online, will use this very precious time to listen and learn from Professor Amanda what she has to tell us about the expertise, experiences, and all practices that she has been through. So I also expect that all the materials today will equip us, especially all of you students who are at the moment start your program with the postgraduate to complete your study. Before I start, I should also introduce you. I would like to read Professor Amanda Rachel Boucher short CVs. Professor Amanda Rachel Boucher, informally, we always call him Mendy. It's a very short one and very friendly and familiar. So let's make this relaxed one, okay? So just relax, take your seat over there, and hope that after presentation, which may take about an hour or so, and we will open for question and answer, and it will be very good opportunity for you to give up your question by calling Mandy, if you like. Once again, Professor Amanda Rachel Boucher has a Bachelor of Applied Science in Coastal Management from the University of New England, a Master of Science in Marine Chemistry from James Cook University, and a PhD in Ecotoxicology from Southern Cross University. She teaches environmental chemistry, biology, aquatic pollution, and catchment management. Mandy also supervised about 14 PhD student completions and has supervised many masters and honors students in their research projects. 30 years experience investigating human impacts of impacts on the environment. Mandy also has published about 100 scientific journals articles and is editor and co-author of a new textbook titled Marine Pollution, Monitoring, Management and Mitigation, published by Springer. And if you look at the background of our presentation today, or Mandy's presentation today, it's actually a book that has been published by Professor Mandy. And perhaps, one of the book has been given to the library of Universitas Pattimura. She has been working with colleagues from the University of Pattimura, that's why Mandy is here, for few decades, and was president of the Asia Pacific Geographic Unit of Society of Environmental Toxicology and Chemistry, CTEC, ANP, from 2020 and 22. Well, we come to the business. So just listen carefully. Unfortunately, I think I'm not going to translate all the details that Mandy is going to tell. So listen carefully, pay attention, and don't worry about the difficult words that maybe she will spell out. Okay, later on you can ask, excuse me, Professor, what's that mean of this word? And I will translate it to you. But I believe that all students, all postgraduate students, before they enter they should enter the postgraduate enroll the postgraduate, they have an English test, proficiency, something like that. So I believe that they also have a very good and capable of saying words in English. Well, before further ado, I will give the time for Professor Bruce to present the talk for us today, about in an hour or so. Thank you so much, Professor.
Terima kasih, Prof. Mose. Terima kasih, Prof. Dominguez. Terima kasih, Ibu dan Bapak. Saya mengerti bahasa Indonesia sedikit saja. So I'm very pleased you have English language, because my bahasa Indonesia is very small. Terima kasih, Patrick. Very beautiful English. You speak better.
You're very welcome.
Excellent, excellent pronunciation, and very, very nicely spoken. So congratulations. So just. No, he just said thank you. Just a little bit of housekeeping. I think I'm holding the presentation, so just checking with AV that I'm letting people who are in the waiting room online join, because I'm admitting new people. I'm going to admit them. Okay. So many of you who are studying postgraduate at University of Pattimura are not all related to marine science. I think some of you are chemistry, some of you are social science, some may be agriculture, and a range of other disciplines. But one important consideration is how you collect your data. And there's basic principles that are relevant to every discipline about quality data for publication and the importance of that quality data for publication. Okay. a couple more people from the waiting room. So let's make a start. Where is Southern Cross University? Well, first you'll see here, this is Ambon. We are 700 kilometres away from the closest part of Australia here in Ambon, which is Darwin, or close to Darwin. But I live further south, and our campuses are on the far east coast of Australia. We have 3 campuses, one on the Gold Coast, one in Lismore, and one in Coffs Harbour. And at the Coffs Harbour campus, we have a National Marine Science Centre where we do a lot of experimental work in marine environments. So there's many people joining, so I'm just letting them in. So there's our 3 campuses. They're quite different. Just having trouble moving forward with my slides. Here we go. So part of the reason why I'm here, I'm not actually on holidays, I'm on study leave. So taking a little bit of holiday while I'm in Indonesia. But earlier this year, in May, I finally published a textbook, which is, as Bob Mosse mentioned, titled Marine Pollution Monitoring, Management and Mitigation. It's 369 pages, it's got 16 chapters, and it's not a book that I've written on my own. It is a combination of collaborations between different experts in different discipline areas. So as Prof. Domingos said, it's really important for University of Pattimura to be collaborating between different disciplines associated with ocean science, ocean law, ocean medicine, etc. So we need to bring together many disciplines in order to be able to do good marine science, understand marine pollution, and also input this into our legal system. So one of the chapters of this book is related to marine law, which is a really important part of how we manage pollution in the environment. So a really good point and a really good thing to consider. It's highly valuable to collaborate and to work with teams and sets of different sets to bring together a really unique combination of research. So to date, actually, this morning I looked and I have had 40,000 chapter downloads. So Endang just handed out a few flyers and you'll see that the QR code is there. You can use your phone to connect directly to that textbook. If you want to click on it up here, you can do that too. The reason why I'm partly promoting this book today is that chapter 2 and chapter 3 are very much related to good field sampling methods and good laboratory methods. And even if marine science is not your discipline, those same principles apply. So once you connect, you'll see there's you'll get to this page, and here you can download the PDF of the whole book, or you can go further and down and scroll down and just download particular chapters if you wish. So one of the really important parts of making this book open access, it cost me a lot of money. I had to pay to Springer to make it open access, but it's really important if we're going to protect the marine environment for future generations and look after it for our children and hand them something that's healthy. We need to share the knowledge about how to improve the marine ecosystems and how to reduce the pollution. So this knowledge is something that I don't want to own, and I don't want it to cost money for people to access it. So use this book as you wish, and always use it as a baseline resource. It's very digestible and very, very easy to understand. The style I have written it in is like conversation. And sometimes it gets deep chemistry where it needs to, so you can explore that as well. So these are the different chapters. You can see that I am author or co-author of 11 of those 16 chapters. But there's some chapters, for example, like plastics, which is such a big topic for marine pollution research that I brought in a number of experts to write that chapter independently. You can also see that there is a real multidisciplinary approach to this type of publication that we do. So what about you? You want to publish? Why publish? You're all here becoming postgraduates. You're working on your postgraduate studies. Your career depends on you publishing. And it's okay to publish your thesis, a nice blue book. I saw many of them in Domingus's office. But it's really important that other people get to hear about your research, because part of what science is, it's building on knowledge that already exists. And your contribution as a scientist, whether it's a social scientist, a biological scientist, or a chemist, is important for us to grow our knowledge as a global society. So my publication, we have what we call ResearchGate or maybe Google Scholar. So we check and measure all our publication performance, not just only the number of publications, but also how many people cite those publications. And those publications, whether they're important and valuable, will be indicated by the number of citations and how popular they are. So in Australia, we look at H-index. We also look at citations, which is linked to H-index. So I was looking the other day for Indonesia, and I found a very interesting research article which was published earlier this year, which was titled Ranking Researchers, Evidence from Indonesia. And this publication highlighted that when the first assessment was done, Indonesia was the second lowest publishing country in the Asia Pacific. It had a very poor publication record. But in 3 years, that turned around, and just recently, Indonesia is now the highest publishing Asia Pacific country. So, congratulations. How did that happen? Well, there's a few things we need to consider. One of them is that CINTA assessment came in during that time, and that CINTA assessment is the Indonesian equivalent to ResearchGate. It also includes your research publications that are written in Bahasa Indonesia. And importantly, that tool, do you use CINTA? Do you have a CINTA profile? Yep. Or you should start a CINTA profile, right? You can include things like conference presentations in these. This gives you a score, and it ranks all the Indonesian academics. So this publication looked at 200,000 Indonesian academics. And what it found is that conference presentations increased by 65%, which is very good. It's great. The number of international publications only increased a small amount. So there's still work to do to share that global knowledge. But a lot of progress has been made in Indonesia. And this paper looks at how did it happen and why, and part of its attribution is the fact that because you have a metric like CINTA to measure with, you see yourself improving and you want to improve and you can compare yourself to others. So you can always then rank yourself against your colleagues and your peers. So it gives you a benchmark and it gives you a goal, you know, a future goal. So this is great. I recommend that you have a look at that publication. But then the other question is, why try to publish in English? It's easy for me. English is my first language, yeah? It's more difficult if English is your second language. Maybe not for Patrick, because Patrick has an excellent grasp of English. But it's really important to recognize that English is the international language of science. So it's the international language, really. So more people will see your work if it's written in English, so you can contribute to the global community more. Also, publication is linked to your career development and grant success. Another reason is it's your obligation as a scientist. It's no use having the cure for cancer in your lab book. No one will find out, right? It's really important to share the knowledge that you get. Your publication will influence your career development and successful promotion. Also, it makes you feel good. It's a very positive thing to do. It gives you a feeling of accomplishment, of achievement. And of course, other scientists want to hear from you. They want to know what type of research is happening in Indonesia. So make your science visible to the global community. And this is a quote from Isaac Newton, one of the most amazing scientists that has ever lived. If I have seen further than others, it is by standing upon the shoulders of giants. He is indicating here that he has been able to further research and further our knowledge because he's had the baseline of other people's research and knowledge to begin with. And we need to understand where our research fits in to the existing knowledge. So think about what's your research topic. It's really important to read, and keep reading. Access the literature, draw upon the existing knowledge, write a critical literature review, and identify how your study will fill a gap in knowledge. It might be locational, it might be new drug discovery, it might be assessment of social community structure in different fishing villages in Indonesia. It all will help contribute to that knowledge gap. Make sure you plan your research and get your supervisor to check your planning. Do good science. If you want to publish in international journals and you're working with animals with a backbone, a vertebrate, you must seek ethics approval. Also, if you're working with people and you're surveying people, if you want to publish in an international journal, you need to seek ethics approval. And maybe the University of Pattimura has an ethics committee now where you can seek approval through that committee internally. Be flexible. Be ready to change direction a little bit. If your research is not working out, think of a way you can make it work out. Think of a solution. Think about what journal you want to publish in straight away. Before you're doing your field collection, what's your target journal? And really importantly, avoid big, broad topics for your first research project. Focus on something that's achievable, has a hypothesis that you can easily test, and you're able to collect comprehensive and representative data that answers the question that your hypothesis. And when you're writing, use And when you're doing your laboratory work or field work, use every opportunity to demonstrate to a reviewer that you care about your work and your results. And we'll see soon this is about quality control and good experimental design. So I can hear all of you saying, but we don't have good access to publications and articles, and it's very difficult for us to get access to these. There's many ways that you can overcome this. So certainly, if you go to ResearchGate, use the reference list of a good paper that you like and find the references that paper cited, and then you can contact the authors via ResearchGate and ask for their publications, and they'll send them to you by email. You can contact the authors through LinkedIn and ask them for their publications. Every author, including me, wants to share their research publications, so in the future you may cite them and then you get a citation. Some frontiers journals, some more and more journals are 100% open, and also in nationally competitive grants, we are now in Australia and in Europe required to provide that information as open access, because it's taxpayers' money that has funded the project. So it's everybody's knowledge to share. So it should not be only dependent on people who have access to the journal subscriptions. So don't let the perceived access limit your literature reviews and your critical assessments. Ask, 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 ask. Keep asking, send emails, put requests in. And also, it's good to have a friend who's at an Australian university and we can help too. Your Thema Smiley sometimes says, Mandy, can you get me this paper? And I can send it to him. So this picture on the side is just a snapshot of my ResearchGate publications, and you can see there it says full text available for the article. Sometimes you can click on this and you get a copy straight away. You don't even have to contact the author. Okay? So Google Scholar is similar. Okay? So just use those different resources to your benefit. Okay, so you're writing a paper, but make sure you have something worth saying, something that makes a difference. Be excited about the research that you do. And to do that, you must know the literature to put your research in context of other studies. That's a really important part of your discussion. What does your data mean in the context of other studies? So when you're thinking about writing a paper, think about what did you do? How did you do it? Why did you do it? What does it mean? So what? What does that mean in the context of the bigger picture? And where do we go from here? How do we build this knowledge? Where's the next knowledge gap that needs to be filled? And importantly, you're a group of postgraduate students here, so get each other to read your work before you submit it to your supervisor. It takes a little bit of time for you to read someone else's work, but then the favour is paid back because someone will read your work. Then when you give it to your supervisor, like Bob or Dominguez or Endang or Mary, it's the best it can be. So then your supervisor is being able to fine-tune it and do corrections that are higher level. So share your cohort, use your cohort. So it's something to remember when we're sampling, whether we're sampling in the environment or whether we're analysing laboratory samples, that this is just a snapshot. So like that photo picture there, the camera takes a photo of a scene, but it's fuzzy around it. We don't know what's happening around it. So almost everything we understand about the way the world works is based on some sort of data. And that data, by its nature, is incomplete and imperfect, all right? We acknowledge that. We are sampling. We can't sample the world, every bit of the world, because there would be nothing left of the world because we've digested all the sediments in the world, for example. So it's really important that we understand that there's imperfection and include these things such as errors in the measurement. But if we've got an understanding of the amount of error associated with our sampling, then our idea of the fuzziness is reduced. So we make inferences about the whole from a fuzzy part of the whole picture. Once we acknowledge this, we know that our sampling methods and approaches can be fine-tuned to be the best type of data that represents that ecosystem we're looking at, or the chemicals that we're looking at. How and what you sample will have a big influence on how fuzzy that picture you get is and the usefulness of your data. So, if we're thinking about field sampling, put your hand up if you take samples in the field for your research, for your postgraduate work. Nobody? Endang did. Yes, Endang, put your hand up. Anyone else? No one has been in the field. No one has been... Really? Are you just shy? Hmm? Put your hand up. Yes. Excellent. I thought I was in the wrong room. Okay, so let's have a little look at this. Sorry. Okay, so when we're thinking about field sampling and also laboratory sampling, we must make sure we have replication. So it's much better if you have a limited budget to look at one location and several replicated sites within that location. And within each of those sites, you take samples maybe of sediment, maybe of oysters, maybe of water. So for example, if we're looking at copper pollution in Ambon Bay, our 3 sites might be inner, middle and outer bay. And then at each of those sites, we have 3 replicates of oysters, 3 replicates of sediments, and 3 replicates of water. And that way, we have data that is able to be statistically analysed and compared. We will understand the variability within sites and between sites. Maybe you're not sampling, maybe you're doing a chemistry-related postgraduate, might be looking at Kachaput oil concentrations from the Kachaput tree in Seram Island. Maybe you're looking at locations, west, centre, east. You could have more than 3 sites. This is an example. You could have 10 sites if you have the budget. 3 is the minimum. You might be looking at trees, so at each site you've got 3 trees. You might be interested in where the oil is concentrated most. Is it the leaf? Is it the bark? Is it the root? So 3 replicates from each of those sites of each of those biota type samples. The same can be said for a social science study. If you're interviewing small artisanal fishermen, you want to interview more than one. You want to ask questions that are quantitative and also ask some questions that are qualitative. The qualitative questions are harder to do analysis on, so you might be seeking out keywords that are introduced into that qualitative analyses. But you can understand a lot about one fishing village, say one location, but what about if you want to know the difference between fishing village A and fishing village B? Then, whoops, let's jump to this. Then you repeat that unit. Repeat the same thing at the second village. You repeat the same thing at the next location. So it might be Ambon Bay, and then it might be Byron Bay, for example. It's close to me. But let's have a go back. If we sample like this and we have many locations and only one sample from each location, we don't have any replication, so we can't do any statistics, we can't understand variability, and our snapshot means nothing. So put your effort and your finances and your money and your funding and your time into the linear approach. Into funding that way, locations, sites and replicates, not many locations with only one sample. Also, when you're sampling, think about what type of behaviour the samples are that you're sampling. Sediments have interesting chemistry, like redox conditions, like grain size, like mineralogy. That's an important part of the picture to collect. But maybe if you're sampling fish, it's not a great idea to sample tuna if you're interested in the location level, because tuna move very far around the ocean. So just because you caught the tuna off Saran, or maybe off Ternate, doesn't mean that tuna lives there all the time. So think about the behaviour of those different species that you might be collecting. Are you interested in environmental pollution or human health maybe? If you're interested in human health with the tuna, maybe you're best to go sampling at the fish markets where people get their food from. And you might sample different fish markets, or several tuna from the fish market, several other fish from the fish market. Think about when we're working with the biological systems, there's often seasonal differences. Maybe there's spawning times, maybe there's migration times, maybe the tide influences the behaviour and where we find the organisms. Maybe if you're working on a chemistry topic, you need to think about, does the compound you're interested in degrade over time? If you sample on Wednesday, will that compound still be there next month in your samples? Are there seasonal differences in the amount of that compound in the plant that you're interested in? Is it better to harvest in wet season or dry season, for example? These are all questions you might answer as part of your research question, but don't ignore those potential factors to be contributing to variability. So here we go, repeat the unit. If you have more funding, you can repeat that unit again, and on we can go, depending on your resources and your funding and the question that you're asking of your hypotheses. Are you looking more locally or are you looking more regionally? So there's a lot of information about this in chapter 2 of that textbook that will go into more detail that you can draw upon. So use that if you would like. Let's think about laboratory experiments. So we've focused on research in the laboratory. Ecotoxicology is a good example. We might be interested in the effects of copper on the health of a bivalve mollusk. Something we eat, maybe, and we want to have aquaculture associated with. It's really important when we're thinking about biological systems, they're more noisy than non-biological systems. So we might like to take more replicates. Rather than just 3, you have more strength of understanding that natural variability with a higher number of replicates. So minimum 3, but maybe 5. Make sure you use environmentally relevant concentrations. It's no use exposing an organism to a concentration that it would never find in the environment. Okay, because yes, you might get a result, but that doesn't have any environmental relevance. Use a fixed number of test organisms in each of your test chambers, and those test chambers are replicated. Allocate the replicates randomly, so you don't have 0, 0, 0, 0. You can see in this diagram here that they're randomly allocated. It takes a little bit of work, but what that ensures is that you don't have an experimental design effect. Okay, so maybe the sunlight's shining in the window on all your controls and you get high algal growth and it looks good. But it's an effect of the environment that you've set up the experiment in. So this design is statistically rigorous and you can do analysis on it and understand if there's a different response between different concentrations of copper. So here's a publication of one of my PhD students, and even though you can see this is effects of copper on fertilization success of a coral species, even though you can see that the data is a little bit noisy, you can see that variability with those data points and the replicates at each concentration. Because we've got those replicates, we can use the grey cloud around that line to have confidence in our results. So we can say, well, the EC50 was 10 micrograms per litre plus or minus 2 micrograms per litre. So we're able to explain how confident we are with the result that we've got. If you only have one data point for each concentration, that line might be very different. So you're not really representing, you're not understanding that snapshot that I was talking about earlier on. And many people have to learn to navigate out of pseudo-replication, all right? You're much better off to have 2 fish in each of 3 control containers than 5 or 6 fish in one, right? If you only, this is your unit, yeah? So you only have a replicate of 1. If the water quality deteriorates in this for some reason, you will assume that the copper has made the difference, but it might be one of the fish was sick. So this is the wrong way to replicate. For each of those concentrations and the control, you should have a minimum of 3 tanks and several fish in each of those tanks. This you cannot publish. You cannot publish this type of work. So I do some work on coral reproduction, and in Australia, corals only spawn 1 time per year. Sometimes 2, depending on the full moon. we might have a split spawning where some colonies spawn 1 month and some colonies spawn the next month after. So it's really important to get as much information as we can on those important nights of spawning, because you only get the opportunity 1 or 2 times a year. So that picture shows our replicates all set up for small fertilization assays in each one of those jars. Very time consuming, it takes a lot of work, it takes a lot of effort, but you get really good results that are publishable. We fix them, we do a fertilization assay, we fix them, and then the next day we count fertilization success. Your experiments, if you're not dependent on the way the organism is behaving or the reproductive cycle, your experiments can be spread out a little bit over weeks maybe. And also, if we just use corals as an example, there are many different test endpoints. So fertilization success is interesting, but the larvae are around for several weeks, and we can investigate motility, how the larvae are moving, maybe survival, maybe settlement before they form into adults. And when we do adult research, we have some serious issues at times with water quality. So we have to have very, very clean flow-through systems. And I'm pretty sure that this video won't work, but I'll give it a go. I don't think it's going to. No. But this is an example. This is one of my replicates, and you can see there is 6 or 7 fragments of coral that represent an individual unit. And each of these tanks is replicated several times, and so on. Pity that doesn't work. But that looks like a pretty complicated setup, but we designed it. So if you don't have the equipment to do the job that you're looking to do, you can, we were photographing those corals and looking at tissue sloughing off the skeleton. So we wanted to take photographs, but we didn't want to put our hand in the water and contaminate the experiment. So we designed a carousel where you can put in a centerpiece and move it around. So take photos from the window of the aquarium, and then we can do the digital analyses on the amount of tissue that's surviving. So be innovative. If there is not material for you to do what you need to do, and there's not the equipment, think about how you might be able to create it yourself, how you might be able to make it. I've made many different types of sampling devices or equipment to do a job that I needed to do, which didn't have a particular sampling device available at the time. So think about, maybe we're looking at laboratory experiments that are chemistry related. Again, you can see this replication is important. But we might be developing a method. Which is the best method to extract bioavailable iron from sediments? We might be looking at different pHs and different extraction times. This is work from one of my PhD students, and you can see in this graph here that the coloured dots are representing the replicates. So he understands how similar each replicate is, and you can see that he's getting really good efficiency after about 4 hours. So why take it to 16 hours if you can complete that process in a shorter period of time? So again, you can see the replicate, and you can see that applies also in method development, not just field sampling, not just ecotoxicology. So, you are all probably younger than me. Yes, I think so. So, we need to recognize that there's been major technological changes in science over the years, particularly in the last 30 years. So when I started my undergraduate, there was the first Apple computers. There were no mouse. There was no mouses, all key commands. The first launch of the first Apple Mac computer was in 1984. First year we had a computer course. No one had a computer. All our assignments were written by hand. And then they said to me, there was a statement that came out that one day every house will have a computer. And now every person has a computer, but maybe two, because your phone is more powerful than this 1979 storage device, 250 megabytes. Your telephone can write a thesis, actually. So you have this amazing resource of technology, but also data storage and power of analysis. So there's a lot of work that's being done these days on big data analysis. There's so much data out there, but what does it mean? So when we're thinking about science, analytical equipment has also advanced incredibly. So 30 or 40 years ago, we were very happy that we could measure things at the level of parts per million, milligrams per litre, milligrams per kilogram. But the technology of the instrumentation has changed so much that now it's very easy for us to measure 3 orders of magnitude lower at parts per billion, and then even at parts per trillion, 3 orders of magnitude lower than that. But what that highlights also is contamination becomes a serious issue, because we're looking at things almost on the atomic level. And if you have a dirty lab, you have rusty pipes, and you're trying to analyze for iron, you're probably going to get contamination. So think about making clean spaces to minimize contamination. It's also really important to support your data with quality assurance and quality control. One simple way to do this is to use certified reference materials. These are reference materials for maybe fish protein, sediments, soil, excuse me. And the certificate of analysis shows the concentrations of different metals that you would expect to find, right? You take a piece of this certified reference material, you process it the same as your other samples, and you must get within 10% of the certificate value. But this is what you put in your publication and show that we had 90 or 95% recovery of a certified reference material. And this shows that your data is believable. So this is a way we can help analyze or understand the accuracy of our results. So accuracy can only be assessed using external calibration standards or reference samples or interlaboratory trials. So if you're sending samples off to Bogle, for example, put in a reference material. Don't tell them. Find out what it is when it comes back. If it comes back poor, 50% recovery, you tell them something's wrong and your samples need to be reanalyzed. You need to have confirmatory results. And to do this, this is one example of what you can do. Also, think about the precision, the confidence, having confidence in meaningful results. So precision is about competence, cleanliness, procedural clarity, the method and the approach, the calibration, and your instrumentation management. So, if you were collecting samples, water samples for a compound that might degrade, maybe a pesticide, in sunlight, you want to collect it in an amber, a dark bottle, like these brown ones here in this picture. Yeah, because it stops the UV light from getting to the sample and degrading the sample. So your sample collection device is important, and the way you store it before analyses. So also, if you're analysing for pesticides and organic compounds, you want to use glass containers, not plastic, because the organic compounds can absorb into the plastic away from the sample that you've collected. And the opposite is true for metals. You want to sample those metals in plastic, usually polycarbonate. So the sample container and what it's made from is also important for the integrity of your samples. And one of the most important things in any laboratory is to have a really good source of pure water, molecule water. So I'm sure your laboratories have something like this, or you have access to this molecule clean water. Make sure you use this and don't compromise. And sometimes also check that this filter is in date. You might send some molecule water off for analyses to make sure your water is not contaminated. You also must have good methodology with equipment. So use pipettes correctly, use glassware correctly. Make sure you know the proper way to use the instrumentation and the glassware and equipment. So you probably get this diagram in first year, yeah? Some of your first year units, but never forget it, yeah? We want accurate and precise data for publishing and to be confident with our results for publishing. So this is what you're aiming for, the last one on the end there. And you can do that by implementing your quality control and quality assurance processes. There's a lot more detail in the chapters of the book about how to do that as well. So if you want further detail, you can access that. Also think about, it's chopped off the bottom there, but I made a note about significant figures. Your accuracy and precision is only significant to the number of figures of your lowest sampling device. So it's usually plus or minus 0.01 or 0.001 of a mil, for example. Any number beyond that is a guesstimate. So don't put in 12.683958, blah, 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 blah. Use the significant figures that are valid for the process that you're using. Your balance may only have 2 significant figures. So that is the limitation of the accuracy that you've got. So it's no use talking about or using a whole heap of decimal places because you have limitations associated with the precision and accuracy of the instruments that you use in the processes that you have in your methodology. So, quality assurance is really important to aim to optimize the reliability of the measurements. So importantly, there's some measurements that are systematic and these don't vary throughout the process, but there's other ones, for example, like contamination, that do potentially vary throughout the process. And they may give you a less than optimal result or a higher than optimal result. So in your methodology for publication, it's very important to briefly explain the quality assurance and quality control processes that you used in your data collection. So just a little bit of a summary. All of you are in some stage of the process through your PhD or master's study. where you're either preparing data, you're looking for data integrity, you're analysing changes in time and space, maybe between location or within sites. You're exploring relationships between parameters, maybe metal concentration and grain size for a sediment, for example. And then you use statistics to compare. And the statistics is able to take note of the variability, but also compare between sites. Once you interpret that data and understand what it means, not only to you, but in the context of the literature that exists, then you write it up and you potentially publish. Or you might need to refine the model and go back and collect new data and support the experiments that you're doing. So Endang here down the front was my PhD student for 4 years. She's just come home to University of Pattimura. Maybe some of you had her as a lecturer, or maybe some of you have worked with her. So Endang has published 1 paper in an international journal. She has 2 more that we're working on. And just yesterday, her examiner's comments came back. And Endang was given an A and a B, which means just minor changes, just small changes. So, I'm very, very proud of Endang, and now she has some changes to make. She resubmits her thesis, and then she's Dr. Jamal. Yeah. Yes? Yeah.
Baru saja kembali dari Australia dan di bawah bimbingan Profesor Amanda Bruce, Mandy, dan sudah mempublikasikan 1 papernya internasional, dan berita terbesarnya adalah Pak Direktur, kemarin berita gembira datang, yaitu hasil ujiannya yang 1 penguji memberikan A, yang 1 penguji memberikan B. Sistem Australia itu setelah kita menulis disertasi atau tesis kita, itu dikirim ke penguji luar negeri untuk diuji. Dan 1 dari Amerika, one from America, from US, and one from Australia, 1 dari Australia, dan 1 memberikan nilai A kepada Ibu Endang, dan 1 memberikan nilai B. Artinya bahwa sudah lulus sebetulnya, ya, sudah lulus. Dan 1 pekerjaan yang sangat besar, sangat berat untuk melalui proses itu semua. Tapi seperti yang tadi dijelaskan oleh Ibu Mandy tadi, bahwa publikasinya yang juga memberikan catatan yang sangat penting, dan prosedur-prosedur metodologi yang baru saja dijelaskan, nanti sebentar kalau ada yang bertanya silakan ditanyakan, itu diikuti dengan ketat, sehingga tidak heran kalau Endang bisa melalui semua proses ini dengan baik dan berhasil. Saya pikir itu singkat dulu. Terima kasih. Thank you, Endang.
Thank you, Bob. So when you stopped me, I had a picture of my feet. But this has more to say, because when you finish a publication, right? And you submit it to a journal. Ooh, what's next? Start the next research project, or paper, or write it up. So you're always doing something. You don't stop just because you make a submission. But it's okay to have a little bit of a rest and celebrate. Celebrate the submission, celebrate the success, be proud of yourself. It's hard work, yeah? It's not easy for everybody. My book took me 4 years. Lucky COVID came because I was stuck at home. So I could write my book. Not lucky. But persevere, celebrate the wins, celebrate your successes, just like Endang will, and Endang has been. But never stop working towards publication. Don't think 1 is enough. Don't think 2 is enough. Keep going, keep going. Work in collaborations. Many of my publications are with collaborations, with University of Pattimura, with our international research laboratories. But when you work in a team, you also get great success. So don't be afraid to commit to a team. So when you get the opportunities, and if someone invites you to a team, say yes. Say, I'm interested. Find time to fit it in, because that opportunity may never come again, and you will be stuck, an isolated researcher. Reach out, work with colleagues, work with people. And one important take-home message is when you're early in your career, your first publication can be very hard. Number one, takes a lot of time, costs money, there's a lot of effort, and it may not be the best quality. It may not be a publication in Nature, but that's okay. That's number one. That's your first one. We all start somewhere. And then number two is a bit easier, a bit less time, a bit less commitment, a bit less cost and effort. And the quality is a bit higher because you have more experience and you more confidence and you know what you're doing. And as time goes on, your quality and the effort that goes into each publication changes. So just don't see the first publication as something that's going to be like every publication. The first publication is the biggest hurdle and maybe not your best work you ever do, but that's okay. It starts the process. You will probably do your best work later on in your career when your brain is full of knowledge and you can put things together and understand big pictures and put your research in good context and tell great stories about your data. So I give everybody the best encouragement to succeed in your postgraduate studies, but also don't stop there, keep going. So thank you, everybody. I'll leave this as my take-home message to you.
So much, Mandy, for what a presentation. Very valuable and lots of points there that we can take and learn from. Now it is the time for us to put forward question. Oh, it's a very good day. Okay, let me identify first. We also have about 83 participants online. Perhaps we will take maybe 4 or 5 admin here, so perhaps 80, let's say, from online. And for those who from online, please raise up also your question if you want to ask questions. But here, I have one. Okay, you can ask direct questions. Sorry, I haven't seen those from online. Chat. Where's the chat? Where's that again? Sorry. Order 17. brothers from online, they didn't raise on their hands or something. Okay. Can you come to the microphone so Mandy can hear your question, please? Thank you. That's
Good
okay.
morning,
Morning.
the Honorable Professor Amanda, and may I have your name, Mr. Professor?
Bob. Bob Marseille.
Bob.
Professor Bob.
Yeah, okay.
I am Sundari Warandi. I really appreciate for the theme, and I'm interested about the method, the labor method for publications. Actually, I got it, but not at all. So, could you tell me more about more details include management and especially how to manage and analyze if we will be in the field for research. Thank you for your explanation.
Mohon maaf, bisa bahasa Indonesianya sedikit saja, bahasa Indonesia.
Lebih banyak, lebih detail untuk metode untuk publikasi, terutama untuk manajemen, pengelolaan, bagaimana cara memanage dan menganalisis ketika kita misalnya melakukan penelitian di lapangan, kita nanti berada di lapangan. Terima kasih.
Okay, thank you.
Okay, so I think the question you're asking is how you manage the processes in the field when you're collecting data. And I think a couple of really important things, like you don't have your computer in the field really, but you can prepare really good data sheets. And sometimes we print these on waterproof paper. If you're in the field and it's wet, we print these on paper that you can take underwater diving, for example. Or you have a field notebook where all your work goes into. It's really important to not use a pen that if it gets wet, it bleeds. So often use a good pencil in the field, but when you're managing your processes in the field, it's just really important to document everything. So having someone or being part of writing down the details about what the tide was, how you're sampling, what the conditions on the day were like, that is an important part of what the resource kit that you use potentially for your publication. But to go into the field, it takes a lot of preparation. So you don't just go, oh, I'm going to the field tomorrow, I'll grab some plastic bags. You've got to plan, make plans, and this is part of the management, I think, what you're asking. So it might take you a week or two to prepare yourself for field sampling. Have you got the right number of bags? Have you got good marker pens that you can label your bags or your containers with that don't rub off or don't fade away? Have you got enough of them? Have you got enough people? Do you need someone who's strong, who can help lift something up? Or do you have a boat booked? Or do you have your vehicles all booked to go? Is it going to be a public holiday and there's no transport that you can use? So planning is how you get success in the field. Also, for sampling many types of samples, one of the techniques or one of the requirements is if you collect the samples in the field, you put them on ice. So you have ice bucket, like we say in Australia, esky. In New Zealand, they say chili bin. But you have a cold box. You buy the ice, you put it in there, and your samples go on that. Okay? So from sampling in the field, coming back to the laboratory is also part of the QA and QC process. Where do you store your samples and how do you store them once you're back at the laboratory? But maybe you're collecting data in the field. So maybe you're doing a transect and you're looking at crab abundance on sandy shores, for example. Have a bit of an understanding about how long it takes you to do one replicate, and then factor that in to how many days you need in the field to collect the data that you need to do. So it's all about planning. I think that is the question that you're asking, but let me know if I've missed something.
Bisa ditangkap, Ibu? Kalau masih ada, silakan. Boleh ditanyakan lagi. Terima kasih ya. Thank you. Oke. Sebelah kanan ada pertanyaannya. Bagus sekali presentasi hari ini, sangat luar biasa. Oke, let's go. Can you mention your name, please?
Thank you for your presentation. It's very good presentation. I'm Maria from Land Management. I wish I can tell you my question in English, but I didn't pass the TOEFL test, so I use bahasa.
Okay, that's all right.
Okay. Menurut Mandy, apakah sebaiknya kita dalam pengambilan sampling itu mengambil semua sampling yang kita butuhkan, atau kita hanya mengambil sebagian yang kita butuhkan, terus kita proses untuk melihat hasil awal apakah data itu signifikan atau tidak? Karena kalau seandainya kita mengambil data secara keseluruhan, itu pasti akan menghabiskan banyak waktu, banyak biaya. So, menurut Mandy, apakah lebih baik kita mengambil data sebagian aja atau seluruh data terus kita analisa? Thank you.
Okay, that's a good question. At the beginning, when we do the field work, do we have to take all samples in order to know at the early stage of the that particular sample, or just representative of that sample?
So maybe depending on how much is known about an area you might be sampling, but it is okay to start with a pilot study. Have you heard pilot study where there's a smaller amount of replication and you just have a little bit of a look and make sure everything's working well? So one, you could do a pilot study, and that can be included in a publication which shows, you know, you did a pilot study and it's a small part of the publication. But if your sampling is time consuming and you have to do it over a number of days, that is okay. But think about the variability window that we were talking about earlier on. So, for example, if the species you're interested in or the sampling zone that you're interested in is the intertidal area, your sampling is going to be very dependent on the tide, right? So you want to sample during low tide, not high tide, because all your sample site will be underwater at high tide. Or maybe you're looking at pelagic fish that come in to that area in high tide. And then you only want to look at high tide. So the parameters that limit your sampling are important, but you try to do the sampling within a reasonable period close to each other, so you're not moving beyond like wet season and dry season, or you're not moving beyond a natural rhythm where you're sampling over that and you're trying to put them all in the same set of replicates. So if you were looking at rainfall and runoff, you would want to be able to compare between wet season and dry season and not have one whole set of data taking a lot of time and you've got your rainfall pattern changing while you're looking at that. So other types of analyses may not be so dependent on those natural variabilities and natural rhythms, but really you need to think about how those might influence the samples that you're collecting and avoid the noise with those natural rhythms. Maybe use them as a comparative, but not within. Does that make sense?
Kalau masih ada, silakan. Sudah cukup? Okay, thank you. Yeah, we can move to the next one. Before I ask our colleagues and friends from online, if you have, could you please raise up your hand? Okay. After this, thank you.
Okay, thank you. I'm Grace. I'm for education management. I asked about how many times do you have to test the sampling for the next two publication? Okay, thank you. About a publication, how many times do we have to test the sampling taken before publication?
How many times do you need to sample before publication?
Okay, thank you.
Okay.
Thank you.
So again, this depends a little bit on the question that you're asking, okay? So let me try and just give some examples. So if we're in the field and say we're looking at oyster contamination, you might sample in replicates, yes, and those replicates provide an understanding of a snapshot in time. But if you want to look at how that changes over the year, you need to sample more frequently. So you've got maybe monthly samples or bi-monthly samples. So your question that you're asking will influence how many times. But say in a laboratory, if you do an experiment, ecotoxicology, or maybe you do method development, you always want to do it more than once to repeat that. So, and you see a beautiful shape of a graph and a line and you go, that looks really good. Can I do it again? And there's many publications that don't do that replication. So you could probably still publish something that's not repeated, but as long as it's got within experiment replication. But how do you know whether you can give that method to somebody if you don't know if you can repeat it again? So it makes a much stronger publication if you can demonstrate that your methodology is repeatable and you're getting the same results. So it is dependent on the question you're asking, and it's dependent on how much time and effort you've got to put the strength and the validity behind your data. I'm not sure what my camera's doing. Camera zoomed in a lot. Oh, my camera was going funny. Turn my computer. Was just make sure she got the answer. Okay.
I think it is now for us to also give the chances to those who are online system at the moment. Please raise up your hand.
Or maybe ask a question in the chat and you can read
Or
it
in a
out.
chat, yes please. In bahasa Indonesia saja, silakan kalau ada yang mau dalam bahasa Indonesia saja. Nanti saya bantu menerjemahkannya. Silakan kalau ada. Silakan dalam bahasa Indonesia saja pertanyaannya. Bagi teman-teman yang ada di online. Sambil menunggu yang di online, silakan yang ada dari ruangan ini untuk bertanya. Okay. Perhaps before, while we are waiting for those who want to raise up your hand, maybe I just want to make a discussion continue a little bit. Perhaps sometimes the questions from students are how many publications that we do need to read before we make a proposal and even start to write. Because, of course, I can understand this is the stage where we start to worry about, we start to get stressed about how many publications that we have to quote or we have to read, if you like. Some of those start smiling, perhaps because that question represents their hearts. Silakan, please.
Yeah, that's a good question, Bob. And I think it does depend a little bit on the discipline area and how much information is available for the topic that you're interested in. But I think it's really important to review to search as much as possible. But you can get a lot of information about is that publication relevant to my study by reading the abstract, okay? So try and collect the publication, read the abstract, and make a little bit of a database. Maybe you can use EndNote and put notes into EndNote, or maybe you just catalogue those publications that you're reading and the ones that are most useful to your research, and then the ones that are supportive material for your research. So usually in a good literature review, a very good literature review, you'd have about 80 to 100 more maybe publications, depending on your discipline area and how much work has been done in that field. But when you move to publication, if it's not a review paper, your publication is usually limited to 40 publications. So you have to know the best of the publications that are relevant to your field to select the best that are most relevant to your publication. And you have to choose. And that's what Endang's doing now, responding to reviewer comments from her second publication. One of the reviewers said, oh, there's too many citations, references, but the other reviewer says, add this one, add this one, add this one. So now we have to balance the two reviewers' comments by finding the ones that are the most important and taking away other ones that are sort of just saying sort of the same thing, but in maybe a different location. So to be able to do that, you have to know the literature well, so you know which ones are the most important publications. And when someone reviews your paper, sometimes they'll go, oh, you didn't cite me, and I'm an expert. Where's that paper I wrote 10 years ago? You haven't cited it. That happens. It's okay, it happens. But what's important is that they know the really important publications in their field or your discipline. So if you've missed those, they will ask the questions, do you really know your subject area? You haven't cited this most important paper. So you need to make sure you value those publications and you create a hierarchy of importance relevant to your subject that you're doing. So how many you read, how many you cite, how many you reference, as best and as most that you can. Don't put a number on it. Don't put a number on it. But always keep finding more. Your job is to keep finding more and more and more.
Okay, thank you, Mandy. There's one question online. It's very good. Let me read the chat. From Eri Tuankota. Eri. She has 2 questions. The first one is about what is the key success of some sampling technique? Can you get it?
Yes, yeah.
Okay,
Can we do one at a time?
Okay, all right, okay. Eri, are you there listening to us? Professor Mandy is answering your question by now. Okay.
The key success of sampling techniques, I think, probably is don't bite off more than you can chew. Right? You're better to have a deep understanding of a few locations rather than a very thin veneer of a lot of locations, because your interpretation in your discussion will be really difficult if you don't have important supportive data. So an example of that is when we're looking at contaminants in sediments. It's really important to characterize the sediment. How much organic material is there? What's the grain size? What's the redox condition? What's the metal or the contaminant concentrations? And often it's really important. The chemistry is really important because really coarse grain size has a very small surface area to volume ratio, so it won't be able to hold as many metals than a really fine grain size. So that important point will contribute to your interpretation. So if you're only collecting sediment samples and looking only at contamination, your interpretation becomes difficult. So collect good data and supportive data that helps you interpret the results that you find rather than the thin veneer of many, many different things.
Okay. The second question is about how to differentiate research of bachelor and master's level.
I think a good bachelor student, you can't. Yeah, a good, excellent bachelor student doing a small research project. Some of my bachelor students have published. Yeah, it just depends on the motivation, the whole package of the student. Are they very bright? Are they engaged? Are they efficient? Are they capable? Can they do multitasking, multidisciplinary? They're good in the field, good in the laboratory, good at writing. If someone, we say they're the whole package. If someone's the whole package, they're going to always be successful. A master's student, or even undergraduate, but some master's students might be very good in the laboratory, but not so good writing, or very good in the field, but not so good in analysis. So they need more support. So it's a supervisor's responsibility to direct the student and support the student to maintain or gain the skills that are relevant to a bachelor or relevant to a master's, right? Your students, right? Your supervisors are training you to become researchers, right? You don't have all the answers as students. You must rely on your supervisor's advice and support to be able to do a really good job. And it's not so bad to understand your own strengths and weaknesses. So yes, I'm really good in the field, but I need support writing. I'm going to improve my writing by doing some extra tutorials or classes to improve my writing, okay? So then where you can improve yourself, yeah? And then I think, yeah, it all depends on the student. I think a master's student probably the opportunity to 100% focus on research, whereas a bachelor is a bit less.
Okay, thank you so much, Mandy. Berharap Eri bisa mengikuti ya dari sana. Oke, silakan kalau masih ada lagi, mungkin beberapa menit lagi kita akan mengakhirinya diskusi hari ini. Oke, ada satu. Silakan, Ibu Mary.
Yeah, okay, thank you very much, Prof. Mandy. I think it is a very interesting presentation, and I have no question, but I have thank you very much for you give many time and information for about the field and the laboratory to publication. Thank you very much for Mandy, and I want to thank you for your access, open access, your book, your book about marine pollution. Monitoring, management, and mitigation. Yeah, I think it is a very good book for our students, but it's helpful for our students, open access in your book. Thank you very much for your book, Prof. Mandy. And I think it is very important lecture for our students and lecture about for the time the publication with students and lecture, it is very important for our academic accreditation. In accreditation, it's the publication with students and lecture. It is very important. It's a requirement for accreditation. An accreditation need for the about 16% publication with lecturer and student integrated. It's much integrated in our curriculum. Okay, therefore I need your experience, your Mandy experience about your publication in your students for Vienna PASCASARJANA students and lecturer. Thank you very much for Andy.
Terima kasih, Ibu Mary. I think we come to the end of our session today, but perhaps I think, may I ask you the last question?
Yes.
Kalau tidak ada lagi, masih ada dari teman-teman di sini? Okay, this is sometimes it becomes a very fundamental questions for all the students, tapi juga menakutkan, kadang-kadang menakutkan ya, scary things. The question is, how do we know our proposal is leading us to discover a new novel or a novelty? Because it becomes a big thing, I think, for all the researcher, I think. And quite often they ask questions, how to know that my work is going to be considered as a new discovery. Am I right? Betul atau? Ya? Looks like they are nodding over there. Goyang kepala, betul dia. Jadi kadang-kadang pertanyaan sederhana kita bahwa apakah research penelitian saya ini dibilang baru. Betul tidak? Betul ya? Okay, thank you. Listen to Professor Bruce.
It's always a big question, but I think one important, there's several different ways you can help ensure this, but one of them is to know the literature, okay? But there's always a lag between what's published and what someone's working on. So I know I have colleagues that I've been working with, and they've been working on something cutting edge and new and discovery, and they're 90% finished, and a publication comes out, which just like the one they're working on. So when I said before, learn to adapt, or you might have a different mechanism, or it might be a different location you're working in. You might not have the brown, grey breaking, blue carbon storage in seagrasses first. You do have is supportive material from another location. So you haven't been the one that has made the first paper, but the next paper is also important because it helps to verify and validate what that first publication was doing. But again, it comes down to understanding the literature and being on top of it all the time. When I said before, read, right up until the day you submit, has anything new come out? Has anything new come out? I had a student that did work on one species of glass shrimp and submitted the paper. While the paper was under review, they did a taxonomic reclassification of the shrimp and made it into 2 species. Lucky for us that my student kept the samples, so with the new classification scheme, he could go back and determine the ratio of the 2 different species and then slightly change the title and modify the title. It was about thermal tolerance and upper thermal tolerance. So you need to stay on top of the literature. But also, I would hope that all of you are working with a supervisor that has some expertise in their field, and that supervisor should have some depth of knowledge about at least what not to do. Like, don't do that because that's already been done by authors A, B, C, and D. Maybe try looking at this. So your supervisor can also be a really good wealth of information. So have those conversations and discussions about what your research proposal is going to be around. What's the general title of your research proposal? But it's interesting because Maluku's province is unique in the world, right, too. So you've got an amazing marine biodiversity and also an amazing terrestrial biodiversity. So it is unique in the world. So anything you do in that area is going to be of interest to other people. Something to consider though, that a lot of master's theses from people who did masters in the past and people who did PhDs in the past are not published. They're just the book that maybe is in your library, right? So make sure, we call this grey literature, right? Make sure you also look at the grey literature. It might stop you from going down what we say, we go down a rabbit burrow. Someone might have already done that and gone down a rabbit, and nothing is the result at the end. So it's good if you also search the grey literature to help guide you in what your proposal should be like. So just think about every year or every couple of years, there's a different group of faces that I would be looking at. And every one of those people has done research projects and masters and PhDs, but not everyone is published in a journal. So the theses are what holds the information. And you can cite a thesis in your publication. That's fine. So grey literature is also important. And for you locally, maybe that's one place that's important to think about your research in your region.
Thank you, Ms. Unfortunately, we have one more questions online. Would that be all right? Okay. Okay, this is from Tono Mahmudin. Let me read his questions. In one research, I plan to have 50 respondents. In fact, when I go there, I only come across with 40 respondents only. Later on, I met 10 of those supposed to be, or 10 people who are not in that research area, on that field anymore. But in the past, they work in that area. The question is, theoretically, can I take those 10 as well? And how can I, is it okay?
Yeah.
The simple question is that okay to also include those 10?
I think you've got a very...
And legitimate, that's a word, legitimate.
Yeah. I think you have a really interesting data set, right? Because you've got 40, I'm assuming it's a survey that was done.
Yeah, that's right, survey.
Yep. So you have 40 respondents, which is a good number for a survey. I mean, I'm assuming also they were from a similar location or from a similar field of work or...
Sorry, Mandy, I should add a little bit more. This is on tourism location.
Oh, okay.
So this about in tourism.
And one location?
In one location.
Okay. So you have a good number. So one location, and then you've got a group of 10 people that previously worked at that location, and they've got something to say and interesting about it. I think you have an interesting comparative response about people who have worked in the industry in that area in the past and people who are currently working in that industry. So you could, hopefully you've got some of the questions in your survey that were quantitative, where you can say a percentage of people believe that, say for example, tourism is increasing and people are spending more dollars for each night they visit. If your respondents in the past did the same survey and they say something different, you can say, it's likely there's been change over time. So maybe think of your group as, just like you've explained, they're not quite the same as the first group, but they add valuable information that takes your study a little bit further. So I wouldn't pool them together, but I would look at them as an extra bit of information.
Okay, thank you so much, Mandy. I think we come to the end of the presentation today. And unfortunately, I couldn't take any more questions. I think that's enough. Once again, we should tepuk tangan untuk Ibu Mandy. Before I me and Mandy get this chair back to the Master of Ceremony. Let me quote again Mandy's presentation, this simple one today, which is from Isaac Newton. I like that one. Begini, saudara-saudara, ada satu pesan yang sangat menarik tadi disampaikan oleh, ada banyak pesan, tapi mungkin saya pakai satu saja. Yang dari Isaac Newton, siapa yang tidak kenal sama Isaac Newton? If I can see further, it's because I stand up on others' shoulders. Kalau saya bisa melihat jauh ke depan, itu berarti saya sementara berdiri di atas pundak seseorang atau beberapa orang. Oke? Berkaitan dengan tema hari ini, Good Sampling and Laboratory Methods for Publication, itu intinya. Jadi kalau kita mau melakukan riset, penelitian sampai pada publikasi, dan menghindari diri dari duplikasi, bahkan kata kuncinya adalah plagiasi, maka kita harus bisa mengakui bahwa saya sementara berdiri di atas pundak seseorang atau sejumlah orang di atas pundak, mengakui hasil penelitian mereka. Belajar, mengapa? Karena kita mempelajari metodologi, bagaimana cara mereka melakukan sampling, bagaimana mereka melakukan pengumpulan data, bagaimana melakukan replikasi dan seterusnya, memilih lokasi-lokasi penelitian dan seterusnya. Tentu kita belajar dari pengalaman-pengalaman orang sebelumnya. Terima kasih.
Baik, terima kasih untuk Prof. Mendy yang telah memberikan pemaparan materi Pascasarjana Universitas Pattimura. Terima kasih juga untuk Profesor Mose yang telah membantu mengarahkan presentasi dan diskusi di hari ini.
We would like to extend our sincere appreciation to Professor Amanda for sharing her valuable insights with us. And also, a special acknowledgement also goes to the moderator, Professor Mose, for leading us in the public lecture sessions today.
Agenda berikutnya adalah penyerahan sertifikat kepada Profesor Amanda Rachel Busey dan juga moderator Profesor Mose yang akan diberikan oleh Direktur Program Pascasarjana Universitas Pattimura dan juga Ibu Wakil Direktur Bidang Akademik.
Now, we are going to proceed to the next agenda of today's occasions. The certificate handover to the valuable distinguished speaker, Professor Amanda Rachel Brusset, and the moderator, Professor Jim Mose. For this moment, we would like to invite the Director of Postgraduate Program, and also, along with him, I would like to invite the Vice Director of Academic Affairs to hand over the certificate.
Ya, bagi Bapak Ibu yang ada di depan boleh tetap mengambil bagian di depan, dan Bapak Ibu hadirin kita akan melakukan sesi foto bersama dengan pembicara, moderator, Pak Direktur dan juga Ibu Wakil Direktur. Bagi para hadirin boleh mengambil tempat di depan panggung.
Ladies and gentlemen, now we are coming to the photo sessions, and all of the invitees, please come forward to the stage and take place together with the speakers, moderator, directors, and the vice director. Ada kan bisa tiga baris, bisa tiga baris. Ya. Oh. Ya, mohon perhatian untuk peserta kuliah tamu yang berada di Zoom agar dapat mengaktifkan kameranya karena fotonya akan dilangsungkan secara bersamaan, baik untuk yang on spot maupun yang secara online mengikuti kuliah hari ini. Mohon dipercepat langkahnya Bapak Ibu. Bisa mau balik dulu. Masih duduk dulu.
Mau bilang saja, baru baca. Buka sana tuh.
Bilang Bapak.
Bapak Ibu hadirin dipersilahkan duduk kembali. Cuma dia mulu kurang maju. Bapak Ibu dimohon untuk duduk kembali. Ya, hadirin sekalian, dengan demikian maka berakhirlah kegiatan kuliah umum kita di hari ini. Kami sampaikan banyak terima kasih kepada pembicara dan juga moderator yang telah mempresentasikan materi yang sangat berguna bagi mahasiswa program Pascasarjana di hari ini. Dan kami juga menyampaikan banyak terima kasih atas partisipasi dari Bapak Ibu hadirin di hari ini. Sampai bertemu di lain kesempatan. Wassalamualaikum warahmatullahi wabarakatuh.
Ladies and gentlemen, we are coming to the end of today's guest lectures. We would like to express our great gratitude for the speakers and also for the moderators. And also thank you for all valuable contributions and participations by the committee and also the invitees. With a heart full of gratitude, we bid farewell for now. Carry the insights gained here into your journeys of learning and growth. Thank you for being a part of this enlightening experience and see you in the next guest lecture.
Ya, terima kasih Bapak Ibu hadirin.